Nice. Hello everybody. And I think we're live. We have no dropped frames. That's always what you check. Let me just check if we are actually live. Yes, we are. Okay. Let's see if I don't know. No, I don't have headset to. Hello. I don't have a. I think maybe the mic is too loud. And there is some noise. I don't have a headset now to check on the noise, but Windows is also very bad at managing audio, like always. Let me just no, it seems fine. Test. Okay, it seems fine. OBS maybe can just I can make a little bit more filtering. This maybe seems a little bit better. All right, we are just going to wait a little bit, like a couple of minutes before we start. We dive into the. Okay, so I'm just going to build the project just because I can. Just because we're waiting. So let's just. Okay, why is. All right. Today the plan. Let me just the plan is show you how so build node. So how one builds a node for my node editor. So because my node editor like essentially reads off DLL files, and like you can custom build some node, some node. So we're going to build a processor, build a node processor that so I'm built a node processor that will take two arrays, let's say, and do operation, do vectors, and do some operation on them. And after that, we are going to be building, we're going to be actually coding the just-in-time parallelization of the node graph. So this will allow us we already have some like graph that can be parallelized very well, but this will allow us to actually even more test the parallelization. And then coding the just-in-time parallelization will require us to will require the following things. Anti-chains, so somehow defining anti-chains. Also defining anti-chains. So here's the thing, just-in-time parallelization, I don't think today we're going to be reaching threats, but we have to make like somehow analyzation high. We have to somehow analyze, we have to define, like make a function that will analyze the node graph and like you want to kind of tell where this can be parallelized, like the branches, and how it's called, maybe figure out the branches. But first, probably defining just a node processor that will take two vectors and do some operations on them will help us. Like for now, what we do have is this. For now, what we have is essentially what I have now here is an example of a graph. Let me just, what I will do is I will just, okay, so the node editor, the last time we worked on the node editor was quite long ago, but actually from that time till now, I have been working on the node editor for adding various features, adding a lot of stuff. So the node editor looks like this. You can like navigate. It's a little bit laggy now because I'm like remoting onto my PC. So this is not actually like, it's incredibly actually fast to render if you have it locally. I'm just remoting there because I have the laptop which streams on YouTube, and I don't want to build on the laptop because this PC is quite more powerful. I can actually like the performance of this PC is like i9 3900 and then 13 gen and then like 64 gigs of RAM and like RTX 4090. So like this PC is quite incredible. The only thing is just the remote connection. The remote connection is kind of laggy. So the node editor. Okay, so let's say we have like this is an example graph that I've done, and essentially I haven't connected this. What this first portion is like, I'm loading a data set here. Okay, I'm loading a data set, CSV data set. And then I'm just making the table column to array. So this is a node processor that converts some column to a given array, to an array. Then the array type is actually inherited from the column itself. So if a column is like filled with integers, it will know that the array is like integers. And then there are some vector reduce operations that are already programmed. So like the length, the minimum, maximum, mean, or what, the sum of the array or whatever. So all of these are already programmed in, and then so from here I'm actually getting the minimum and maximum of the longitude and latitude, but I haven't connected them already to the min and max because this data set is quite big and it takes a lot of time to like to load. So I have just hard-coded it here in generic inputs. I have hard-coded the minimum and maximums. So what I'm seeing that what I was playing with something here on adding freezing of nodes. So I will just I will make this new branch and this freeze, because freezing of because I see that something I have broken. I have broken something, so I will just reset def to here with hard changes. So after loading, so I will rebuild the program, but that doesn't matter. After loading. After getting the minimum and longitude, the minimum maximum of longitude and latitude, I can TMS extract tiles from some like open services and get a map actually working, and then I can standardize the images, get some like image metadata if I need, what kind of images are there. And then blend them, and then like here is just an example of how you can convert an image to a raw data and then convert that back to an image. So if I now execute that, I should be seeing here a blended image, and then this here actually is just like this is the blend, no, but now it doesn't work in real time here, like adjusting this doesn't work in real time because you have to click execute because some graphs will take a lot of time to execute. Now the idea is then to make parallelization work. So like when you have these kind of nodes that are independent of each other, so these things can execute in parallel, and then the another idea is just to like make some nodes being clever enough to know when like you're adjusting this factor, and if you want to some like real-time adjustments to enable real-time adjustments. Now like you can freeze nodes and unfreeze them, but this I will just now remove because I have hindered something in the how like the right click maneuvering, because I will fix that later. For now we'll just say we have no ability to freeze or unfreeze nodes, but that will be added later. The thing is that anyone like can build a node extremely easily, and like here we have a project where let's say that like this image to raw data node, right? So essentially it's just like every node defines its own structure, and there are like some things that a node has to define, and then there are inputs and outputs properties that are registered inside the node. And what is really interesting is that the node editor knows how to render out so whatever node we define, this is some older graph, import this is the new graph. Whatever we define here, like as inputs and outputs, the node editor will automatically infer their types from our definitions and will know how to render them. So like, for example, min and max are sliders here because there are actually integers. Doubles in this case, right? And when we plug in here, then there you cannot adjust. And all this is like inspired by Blender. So Blender has this incredibly cool node editor, shader editor. But in Blender, you cannot define your own nodes. Instead, like you are defining them in Python. And then you are kind of exposing parameters the same way we do here. But this is like, you have to like one more step, like do Python and blah, blah, blah. Maybe you can actually find them in C++ in like, or C in Blender, but I'm not sure. What I know is that like you can define some node groups in Blender that like are made of more nodes, and then you can have nodes that actually kind of have Python scripts in them. But here it's like pure C++. You're defining this node in pure C++. And the only thing like the node receives are some inputs, and then you're filling out the outputs. And what here is like vector node that is defined in a way that like you have a typed array, which is a vector. It comes with some operation, and it comes some result. This is a reduce node, right? Vector reduce, some numeric result. And then you're defining what kind of operations there can be, like an unknown. And then what you're getting in the process, you're getting some inputs. From the inputs, you're gathering the data, you're getting the operation. And then you're doing a little bit of template magic. Hi, how are you doing? We're doing well. We're kind of now in a C++. I mean, we're always C++. We develop something in C++, but now we're actually like a lot. This is pure C++. So I'm really happy to be developing this stuff, because like, let's see here, the dispatch by value function is what it does is actually just like a templated function where you're receiving some kind of function as a template, and then according to the value of the type, you're calling this function with different types. And the function that you're giving here can actually then infer what type it is, and you can statically cast. And this is what like Rust is doing in the way of like, I don't know if actually probably you can do that in Rust, but this is statically compiled, so it should be extremely fast. And today let's just open up. Let's go coding, and let's make what we want is math vector. We already have that header, but we want like a vector with vector. So we want no, we can be in the same header, so I don't need to copy this. We can just be here. If I do Control and M and O, it will close all of these things. And now I have a structure that are like math, vector, and x, and then I'm here inferring for int 64 and double. This is a vector operation with int 64 and with double. I'm just going to I'm not going to copy this. Should I copy this? No, I could copy this here, and I could make a simple node. Let's make a node that will be math vector. So this will be operation between a vector and a vector. So what you have to do is just name the node. It's just math vector with vector, or I don't know, like should we math two vectors, or vector up vector, I don't know, however you want to name this node, doesn't matter. Okay, so what are you going to do? What we can do with C++? We are going to be programming today. So in the description is just a quick thing. We are going to be programming now I'm doing a node. In C++ you can do tons of things, but we're coding our own node editor. And a node editor is just like you can Google it. It's just a software that allows you to play with nodes, and each node does some operation. It's a kind of functional programming, but actually you're doing it visually. So if I just go back to our project and I run that, and I will show you. So this is the node editor, and then you see that each of these nodes are some operation that we're doing, and this operation has some inputs and outputs, and it's actually like each node represents a function, and you are passing on some inputs and you're giving some outputs, and you can customize you can make your own nodes, you can make your own you can make your own graphs, and it's all like serialized, so you can save them or you can load them, whatever. And yeah, kind of cool things. And we're developing this from scratch. So in C++, it's pretty hard to develop something from scratch, but the node editor, it took me like half a year to develop this, which is not that bad for one person job, considering Blender has a team that develops the node editor. But maybe Blender should consider hiring me. No, I'm just kidding. Reduce math vector with vector. So make whatever this is, like math math operations onto vectors. Math vector with vector. Yeah, it's fine, whatever. Every node has to have its own GUI ID, which can be created just here. Just simply there is a tool in Visual Studio to create this GUID. So every node has this unique GUID, and we're just plugging this GUID here. Also, there is hot reloading. I forgot to mention that, but I haven't set it up properly right now, so we don't have hot reloading. Maybe until the end of the stream we'll set it up properly. So we receive now because we have two vectors, we will receive A and B properties. We define vector A, vector B, which is like raw data, or not raw data, maybe vector A, vector B. Then there's some operation, and then the result is also a vector. Should also be a vector. Output result should be a typed array, and this should be result. Vector result. Now, because we have to register these properties typed array properties is just essentially like template magic. You can do a lot of things with templates in C++. Not a lot of people know that. Register an operation. Now the operation should be like, okay, addition between two vectors. Oh, maybe it's not. Should be. It should be like component wise math. This should be the name of the node. Operations, math operations on components of two vectors, because we are actually getting each component. We're adding each component up. We have to add. We can do subtract. We can do multiplication. We can do division. What else are there? Binary operations. So we can do, of course, XOR. Or whatever else binary operation we come up with, we can do it, right? So now there's data A and data B, because we have input A property and input B property. There is this operation. Then now it's kind of You see here there is a problem, because what if we receive one of the vectors to be like doubles and one of the vectors to be integers? And now we have a problem. Now we have to say that, okay, we kind of prioritize. This is the same thing that happens, the same problem that happens with in C++, right? When like you have some, let's say you have some like int a equals 3, and then you have some double b equals 5.3 or whatever. And then when you do like a times b, it's what operation are we doing here? Or integer multiplication or double multiplication? What if I do auto c equals a times b? The question is, what type is c, right? So is it integer or is it double? And are you actually saying that, okay, c is should be double because this is a wider range? Or are you saying actually that this is an integer? And C++ takes it as the wider range, because the wider the value is, then this value can represent something that is smaller. But the problem here is that this of course is a warning in C. So this is the, maybe the mic is too loud. Let me just, okay. So this is a warning in C++. So we kind of need the same warning here. Okay, so how do we do that? We can do a.get value type, and then we can say, okay, this if a.get value type is not equal to b.get value type. Value type is just a structure that just represents what kind of value do we have. Do we have an int 16, 34, 64? This is the same thing as like if you know this std variant. Is like in C++ 20, but we're using C++ 17 and we have our own variants. So get value type, if it's not equal, then I kind of wanna make a warning here and say that, okay, value types of inputs and b don't match. For now, I will take input a as a fixed value, and we'll kind of work our way only for like fixed value for a. Then we can do some logic where like we check which is wider and whatnot, but I'm not going to complicate things here any further. Now the vec here is like okay, so what if a and b are empty? A and b cannot be empty. This is pretty obvious, because typed arrays cannot be empty. So let's just do a data is like a to vector, and then b data is b to vector. This type here will convert them, will reinterpret this, doesn't cost it. Not this function, it doesn't cast, which kind of, this is bad. We kind of need to cast b to some type before we do that. We kind of need to say, oh, was there like, did I implement cast too? No, I did not. I only implemented to vector. Okay, so what we can do is like we can dispatch another function here, but according to the B type. And then what we can say is that if const expression, okay, first these things are actually valid. Maybe we can maybe even do better. But let's say if it's if the type is arithmetic, then we say const. We kind of say const out of b data is like b to vector t. Then we kind of need to transform this data. There is this function std transform, yes, which takes b data dot begin, b data dot end. Then there is some like vector b. Let's say b casted will be some vector. And now what you have to do is to dispatch a function here according to the A type. No, you can't do that. You need inside this, you need this function inside this function, which is kind of bad for code generation, because this function generates a couple of functions and this function generates a couple of internal functions. But because we're using const expression, it should not be that bad. Okay, so we're generating a function according to the B type, which can kind of transform this vector. Oh no, we don't even need to do that. We can just make it clever here. And we can just do that. And inside this function, we can make this. And this now kind of covers all of the cases that we can get. So we're transforming that to A data, we're transforming to B data using this type. This type gets overwritten, and then okay, then now the operations here that we're getting have to have kind of, so like, what operations do we have? These here operations. Now, because we have these here operations, all of these operations can be actually supported by not the transform, but there was like the no, for each, but for each does not zip. No, the thing is that the std library contains really cool functions. Like std transform, there's std reduce, there's std I don't know, there's no zip, but there's like std for each. All of these functions kind of can be then parallelized themselves and accelerated. There is this for each n. No, this just gives n. But is there a function that enumerates, or does like the basic I don't know, like I want to do it with std functions because they can be parallelized. That's the whole parallelization. We can apply this for each, std for each, and then with an index. Oh, I see, like the pointers. You can get the pointers, but no, please don't do that, because this is then like does not work with parallel execution policy. Please don't do that. This is the same thing. Please don't do that. Enumerate. He defines a function. he defines a function, but then this cannot be parallelized. This was kind of interesting, like the addresses, like you're getting the value of this address and then the value of the 0th address, which is not that actually expensive because this is already like, I don't know, no, I mean the basic approach is just doing that, right? Oh, also, like you have to check if a dot size is not b dot size, then we kind of want to just kind of throw an error because there's no way to do mathematical operations without like just there's no component-wise definition. So sizes of inputs A and B don't match. This will throw the error. Now that the sizes are equal, we can do const size. Is this int or size t? This is int. Constant size is a dot size. Then what we can do is we can even do like a templated function here, but whatever. Size, and now the result is a vector of type. This is std vector of type this result, which has size, and our result of I is of course a data of I plus b data of I. Let's just do that here, and let's just break. So, oh, and then now what if they're not equal now, right? So we have to static cast to t this data. Okay, and then we kind of have the same for all 4 operations, but here it's like negative, this is multiplication, this is division, this is XOR, unsupported operation. Okay, so this can be parallelized itself, so we'll just leave it for now like this, just to see if this will work. Okay, so now what I can see is that I can just build this project, see if there will be, okay, there are some errors. There are some errors because XOR is probably not defined on some types. Let's just delete XOR. Let's just delete XOR for now because I'm not going to define operators on some weird types now. For the sake of the demonstration, this is not okay. Boolean. Of course, if it's Boolean, there's no division. But if it's Boolean, like if this data is arithmetic t, and std, and probably like std is same t and boolean. There was this value thing. Maybe this will work. Okay, now this got built. Now we have this processor, and when I open my notator right now, and I go, let's go to the same graph, whatever, I can now add this component. Oh, of course I cannot add because we have not registered it. We have to register it. Okay, to register it, we have to go to the extension host, and here we have like all of these hosts, these extensions registered. We have to, where is this math vector is already here. This is, what was this, math vector we called it, math vector, okay. Yeah, math vector, there's no other definition. I think there's no other operation of, now that we have registered it, I can open the same graph and I can say component wise math. Where do I get this? Did I not? Okay, something, maybe the UID was wrong. Math vector, math vector. No, the UID, I think we added the new UID. Yes, we did. Type the arrays. Did we actually make? Yeah. We have the new UID here. Of course, this is so stupid. We have to update the create instance function. So stupid. The create instance is just like creates the instance of the object and just like casts it to a normal object. These are proprietary types that no other software has. Components, now you see the two vectors, A and B, and then there's the operation and there's the result. Okay, so let's make a new graph. There's no clear graph, but I can do that, and I can do X, and it just clears the graph. So I can make a, no, why did I clear the whole graph? I could just load it. Okay, let's just try this. Let's make a generic input node. Let's make a generic input node, and we'll load a generic file. We'll load an image, a TIFF image, and we have to load the image. We have to make a load image node. Now, because this is an image and this is a workspace data source, it actually just kind of says that like hi, there's like typed conversion applied. There's like native typed conversions that the node editor kind of knows like to apply and to not apply. And like there is like its own graph for type conversion. So like if you have a type conversion that is like you want to convert some thing to a string, but this thing can be converted first to an integer and then the integer to a string, that the graph will know how to convert that, which is pretty cool. I don't think even Blender has that. I'm not sure. I'm not sure how Blender handles that internally, but we handle it with a separate graph there, which is kind of cool. Really cool. Then we can get the metadata of this node, this image, and we can okay, let's just add a generic output node just to see. I don't know, we are interested in the, I don't know, in the height of the image, right? So now we can convert the image to raw. Is like we can get the data. Then there is a node that will convert raw to image, raw data to image, and this node will get like the width, the height, and pixel data and format, and the data, and it should convert this data to an image. But to trigger this node, for now, there's no way to trigger this node if you don't do something like let's say that we're still checking the height, because the only, oh yeah, you can have the same. Let's first, I don't know. Let's do something. Let's do something interesting. Let's do a string here, which is height 2. Then now this is a string. Then now when I convert height to a string, oh, the integer to a string doesn't work. Okay, maybe I don't have that coded yet. But integer, let's say height. I'm just gonna delete that node. Let's make a generic output node again. I haven't added remove. Generic. I'm height 1, and then height 2. Height 22. Why did I fucking do that? Whatever. Height 22. Height 1. The only nodes that can trigger execution are the generic output nodes. But I will make it possible to the execution to be triggered from any nodes. But that's some other way to. But okay, so we make this raw image, and now when we execute this graph, we should. The image that it gets here is like, okay, this is the image, right? Then it converts to a raw data, and then the image to get it here should be the same, and it is the same. But now in here, inside this, the data conversion, what we can do is we can say, okay, let's add a vector and decimal node, which kind of does some operation, and let's add it like 0.1. And now if I execute this, I should see that this image is a little bit brighter than this image. Or maybe 0.1 wasn't. What kind of type do we have here? Let's add 0.5. Maybe we have some other type here. Interesting. Okay, now this works. Okay, so let's say 0.1 for multiplication. I don't know why addition didn't work, but let's. 0.1 is just too dark. 1.1 actually, I was thinking of this. No, did I execute it? Maybe 1.4 will be more visible. Or am I selecting something that doesn't execute? Okay, now it executes. What's the 3? What? Okay, this is too bright. No, I'm just guessing. Why did 1.1 this doesn't work? Maybe it did work, but maybe it's just too small to notice. Maybe I have box here. 2 works. But 1.9. It's quite weird. What? Let's make add, and then let's just do like 3. Oh no, I don't know. I have to check this note, but this seems to be broken somehow. Okay, it doesn't really matter. It matters that we have from this image, we have now brightened this image, right? But now what we can do is we can add another, I don't know, decimal math decimal node, right? Now, if I'm correct, if I now divide this image by 2, and if I combine these nodes in component-wise math, But no, I'm not. Maybe I'm not correct. I have a times 2, then b times b divided by 2. What is this now? Should I expect the same, or should I not expect the same? No, I should not expect the same. Of course, the division here will make quite another. But okay, so we have some result that we're getting. We're probably just what we should expect the same is like if I add 2 and if I add like -2 here, then when I add both of them I should kind of expect the same, which is true. I expect the same image to be here and here. They look to me the same. But we'll kind of want to. Okay, so let's add like a lot here. Then like this is broken. Okay, so -2 and 2. And this should be the same. But okay, this doesn't really matter. But what it matters to us, it's that I can add now multiple nodes here in these chains. So like I can just for fun add multiple of these nodes. And then I can, for fun, add multiple of these nodes, right? And then when I execute this, I execute it all, and then I get the same image. Okay. Now in the timings, we can see that each node took like 60 milliseconds, 60 milliseconds to execute. This is quite usual. Let me just oh, this is too bright. I'm not making it brighter, right? Maybe I the aperture down. Okay, so this is quite usual because what we're seeing here is that we have to edit a whole like 24 million integers. We have to make an operation on 24 million integers because there's 24 megapixel image. This is quite a huge image, actually, 24 megapixel image. So each node makes 24 million operations, and then it just gets this on the end, like just goes through all of these components, and then it redoes the image. But all of these, because these takes a lot of operations, we can kind of make them in half because we have 2 branches here. If I parallelize this on one thread and on the other thread, I should be getting quite a smaller amount of operations. Also, what I can do now is I was thinking if I could add like a lot more, but just to see like this. Whoop. No, maybe it's enough. Maybe it's enough. But okay, so let's just save this. Let's just export this graph. Let's just export them where all graphs now live. This is let's say A50. Oh no, 50. I don't know. 51. Okay, let's say like that. Now that we have this graph, let's work on the JIT, the just-in-time parallelization. Okay. The just-in-time parallelization. First, what's going on is how much? We're streaming 1 hour. Okay. Just-in-time parallelization. First, like this, we have here. Let's just do that. We have the node graph here. We can add nodes, remove nodes, add edges. The executions are here. Then there is like find. There are actually kind of other interesting things in the node graph that you can do. But not like that. I want this. Let's just close that off. Okay, so these are all the stores that we have in the node graph. I want to now make a function about analyzation of the node graph. So this should be an internal function for now, private function, that will say like analyze and this function I don't want it here, I kind of want it more here. So this function should gather information about how the graph should be executed before the graph is executed. But there is another thing in JIT parallelization where you have most of the just-in-time parallelization work on the instruction level, but we are here working on we are kind of working on an abstraction level, and cookies, whatever. Performance testing the JIT compiler. Okay, this is JIT compiler. And here's the thing, there are two ways how to gather data. One way is to gather real-time data while the graph is executing. So so we are executing the graph first, as we don't have any parallelization whatsoever. And then we suddenly say that this node takes a while, right, to execute. Since this node takes a while to execute, are there any other nodes that can be executed in the anti-chain of this node? So are there any other nodes that can be executed while this node is being executed? And this is the whole idea. But to gather this, we cannot execute the graph in DFS way like we're doing right now. So right now what we're doing is we're saying what nodes, I'm executing nodes that only are required, right? But also I'm executing them immediately in like one go. I kind of need to rewrite this and say, okay, I'm going to execute them, but with a BFS way. So here's the thing, what we're going to do. When I'm executing one node, so first find the output node. Okay, so this is executing one output node. But it is also interesting to say, okay, we're not executing just one output node at the same time. We can be executing multiple output nodes at the same time, which kind of even makes it better, because if we have multiple graphs that can be executed parallelly, we can just do that, which is kind of cool. So I can accept here on the analyze function, I can accept a vector of nodes to execute. And this vector of nodes should be seen as a graph itself. So first, should we first see, are there independent components in this execution? So if there are independent components, so first what we want to see is, okay, I'm executing this node, I want to execute this node, and I'm executing this node. I want to see, is the components are components separate, independent of each other, or is it just one component? Maybe group by components, and then analyze each component separately, and then do that. So there is a function, get topological order by components, get all of the nodes inside of all of the given components. Get all nodes inside component ID. Run a topological sort. Okay, so I first have to realize, because this is coded half a year ago, so I don't know, maybe more. So yeah, this is coded like on 13th of January, so I have to oh yeah, half a year. So I have to realize what I was doing here. Get all nodes in the component is a function that just simply goes through, gets this node, pushes this node, it gets all of the, yeah, this function kind of gets all of the nodes, either on the what are dependent on this node or what are in front of this node. So, but here's another idea. What if I have nodes that are dependent on the executable, on the execution node? And then there are nodes that are dependent on the execution node here. I don't quite need these nodes. I quite need I need just to say that are the nodes that are dependent, are the nodes that I'm depending on different components or not. Get topological order by component, get all nodes in component, and then, okay, let's do a function that it says get all nodes or should we just, in analyze function, we could just do that. We could just say this. Find all dependencies of all of the nodes to execute. So these are nodes that we know that are going to be executed. Find all nodes that we know that are going to be executed. we have to realize that, okay, these nodes are going to be executed. We have to, what else do we have to do? We have to check if there are multiple components, so divide them into multiple components. Check if there are multiple components. For each component, we have to what do we have to do? For each component, what keyboard are you using? High, mean. So we're coding just-in-time parallelization for our node editor. You can go on like for the previous a little bit on the live stream to see what we're doing. Actually, I'm using the Lemo key. The Lemo key. What was the P1? I forgot about the P1 Pro. Lemo key P1 Pro. This pretty cool keyboard. Extremely nice keyboard. I'm not sponsored by them in any case, but it's just an amazing keyboard. For each, I had an Apple keyboard, but I broke it, so I had to buy a new one. For each component, we have to analyze the anti-chains, and execute the nodes in buffer order. And then when we're executing these nodes, while we are executing these nodes, so these kind of things should be actually like in the execute function. So we kind of have to rewrite the execute function, do we? Don't we? While we're executing these nodes, try to parallelization. Try to apply parallelization. Okay. So these things here will be in the execute function. So the analyze function will do just this. I don't even think that there should be an analyze function. Maybe we just say that, okay, we kind of, yeah, okay, let's do that. Let's just say this. We kind of want that. Also, execute nodes. I will change that later. Execute vector node nodes. Let's tell it exit code. Find the output node. The parameter output node is not found. Okay, so here is just like, okay, we check if the output nodes have been found. Execute implementation executes the nodes, but by ID. Reverse map. Because we're not using actual pointers, because pointers can be wild. We're usually using IDs. Performance, yes, okay, this is the performance scoped. What we're going to do is we're going to check this. So first validate. So validate all output nodes. IDs. Validate all output nodes. Should we execute if some nodes don't execute? I don't know. We'll see. Node get RB. This gets the pointer. Output node, and then one output node not found. Then we're returning this output node not found execution. Otherwise, we say IDs pushback and reverse node map IT second. So this is validation of all output nodes. Now we find all nodes that are going to be executed. And this is just simple BFS. We're going to maybe like I'm supposed to like do that in one function. Like find just the topological order of like all of these nodes that are going to be executed. But this is done the same, so the execution of this here execute timopala is no, this just executes this. This function just kind of goes and executes the nodes. It just checks like about the requirements, checks about if like all of the requirements are blah blah blah, and then like just goes and executes, sets the execution status to in progress, checks if it's extension, if it's function, it executes it, and kind of here measures the scoped performance. The scoped performance is pretty accurate because it measures like CPU time, CPU cycles, blah blah blah, measures all hello, it measures all of these things, and then it then outputs this. So in order to find all of the nodes that are executed, let's just code it from scratch. Let's just let's just take this get all components, whatever, all nodes in component, and we'll just modify this, because this just says that okay, there are some visited nodes, this pushing back, I'm pushing here, but this is only the only thing I want from here. Get all nodes in component. Yeah, let's do another. Let's do here get all nodes in component. Let's do boolean depends only. And this boolean depends only will do the following thing. It will say that the reverse, if it's not depends only, then I'm going to do the reverse as well. So I can just now kind of say get all nodes in component. I can say where was this function? Execute. Oh, this is stupid. Oh, come on. Execute this, get all components in node. Then for each node, for each ID in IDs, maybe we should name this better, node IDs. Node IDs. In each ID, we're going to get the component, and depends only is going to be true. And this is auto in component. All of these nodes are in the component. Now we have to kind of match components between each other. But why do that instead of just making this function like std vector int nodes here, and then I don't even need to do that, but I can just, instead of pushing the node ID, I can just push all of the nodes here. For auto node in nodes q.push node, right? And now I can redefine this function and say that, okay, this is vector in nodes. Yes, now we'll break some things, but we'll fix them later. Now append here on core append, this is the same thing as I'm saying, okay, full components. As I'm saying full components is like get all nodes in component, and then I'm supplying the components, and then yeah, I'm kind of doing that, and now I simplified this get topological order by components. I'm not sure why was this used, get topological order by components, but we're going to rewrite this function here. Now here, get all nodes in the component, get all nodes that we know that are going to be executed, and this is node IDs, right? So let's just, okay. This is all nodes going to be executed deferred, or no, not deferred. To execute. These are all nodes executed. Now we have to check if there are multiple components. If one node here some execution and some other execution, and then there are some like other node that kind of executes from some other component. Okay, what's the plan here? The plan is to get all nodes. Okay, so how do we efficiently know that there is some one node here that executes, and there may be like 2 or 3 other nodes here that kind of execute in this component? So this function will return absolutely all of the nodes, but I want to return them by kind of component, right? Because these components can be executed in parallel. But should they be executed should they always be executed in parallel? That's the kind of crucial idea. Okay, let's say that for now we have like to deal with one component, but we can simplify this. But I can like do a DSU here, and then, but no, DSU will require knowing edges. I don't want to know edges. I want to just quickly say that no, why are we thinking that this graph is huge? No, this graph is not huge. We can make some quadratic time. Think. But it's like everything is like in n log n here. And even we're using some things and there's nothing quadratic here. That's why I don't really want to make anything quadratic. I get all nodes, then like, okay, so let's execute Okay, so let's get all nodes back to components. Check if there are multiple components. Okay, let's say that I don't know. So like. It's different if we analyze them component by component and say that this is kind of, yeah, okay, let's kind of program it another way. Say, okay, for each node in node IDs, we kind of want to say what nodes are in this, and then std map, I'm mapping a node to the lowest ID, node to component. I can go and I can get this. I can auto in component say get all nodes in component, and this is node, and then depends only it's true. Then I can say that int ID. Should we make I'll say this. And then for each of the nodes in the component itself, so for each I in component dot size, if node to component did we have some DSU here implemented already, or we didn't have some DSU? Not sure. Let's just Google. Let's just say DSU. No, DSU structure. Struct DSU. No. Okay, let's implement one DSU that we have here. Should be quite easy. Yeah, let's implement it after the edges. Struct DSU. I have it already here, so I can just copy it. Come on. offset. Okay. I will make maybe another file with the DSU and then but it's okay. Now I can do DSU, and then this is the size of the graph. But I'm not. What is now? Why end nodes? Is it size? Okay. And nodes. Now that we have this DSU, we can say that, okay, get all we kind of want now DSU, we want to merge yeah, here is the thing. We kind of want to do that, right? And then the ID is mnodes.size, and we can just merge the ID and in component and this mnodes is unordered index store, yes. So the merging of these this is done. So we kind of merge each node with what component it is, the ID of this component, and we want to increment the component ID. But now that we have multiple components that are the same, we want to know how many components are there that they're like the same, and then they are used. So for mnodes.size to ID, this is component ID. If so, we kind of have that components. We kind of know that there's at least one at least one component that is mnodes size. This const offset. Maybe this is better because we know that the offset here is like mnode size. We know that this is the component at least, and then we say plus n here, plus 1 here. DSU are same if they're not the same components as offset and component and I. then we kind of want component that push back I. Now that we have all of these, what are the IDs of the components? We can make them into like nodes that are like executable nodes. But okay, so what is the, okay, so we have the components. Check if there's multiple components. The trick is here is that, okay, let's just say that platform in log info component count is components.size. Components.size. Okay, before we go any further, let's try executing. Let's try executing this. Execution status. Oh, execution status success. Let's say let's return that. Now that we have this execute nodes, the execution status. Now this function execute. Now we have to go to the control. What is this? Controller node editor controller, and in the node editor controller, when we execute nodes, execute shape layer nodes, there are many nodes that we kind of execute, and now the problem is yeah, so many nodes that we execute. But they're disabled in the standalone version. The only nodes, generic IO nodes, are enabled. This is for another software. So we get nodes by implementation ID generic output nodes. We're getting the output nodes, and we're saying, okay, now this is the thing, is that we have selection nodes execution policy. This I will delete, and I will say, I can say graph execute, and then I can provide output nodes. Also graph output, okay, blah blah blah, that is not important. That is not important here. The only important is like the result. Okay, and now this should tell us how many components are we having. Okay, so there are some issues exist, of course. Okay, this is easy, this is just a manager, or maybe we should accept CSD. There is this thing here. Execute from source node to target node. Yeah. The problem is that this execute, if execute, then like maybe this, but there should be on the node editor controller side. If I'm executing, yeah, no, this is another function execute, so this should be fine. Okay, some other small errors. Yeah, size t. Okay, let's just cast that to int. Okay, let's some other small error. What is this now? What is this policy? Oh, this is inside the node engine. There's like the CLI here. Nothing here, just output nodes, executing output nodes. For each output nodes, the thing is now that we can just get to the graph and execute them all at once. Here it wasn't the case. Okay, I think now should work. And now we need to get the exact amount of components, if we call it this, and we kind of need to make some tests about that. But okay, let's say we get the exact amount of components. Each component will have the nodes to execute, but they're not in topological order. Right? So do we get again? Oh. So here, when I click execute, it should get me component count 1 here. And then let's make another node here, another node here, generic output nodes. Now I get component number 2. Let's get this output node, let's get it here. Now that's component number 3. No, that's not correct. No, 3 was correct when this is the case. When this is the case, should not be 3, should be 2. Components merge the in this component. Get almost in the component of this node, through the merge them. The component ID, the component ID and this node. Can you call the calculator? Depends on how complex you want the calculator to be, you know, like anyone can code a calculator which is easy to do, but depends on how complex the calculator can be. It depends on what kind of functions you want. So do you want to code the functions from scratch? Do you want all the functions to be, I don't know, like, depends, do you want, like, maybe in assembly you want the calculator to be. But of course we can call the calculator, but I'm just, I'm coding something here way more complex than a calculator. No, in binary. What means in binary? In ones and zeros. I mean, I just why? I won't do it. I have called it in assembly, but that was a long time ago, and there was NASM. I've called it in NASM. If you know what is NASM, like NASM assembler. This thing, cross-white. There was like Linux. I remember it was like on Linux. NetWhite assembler. This thing. That was some time. What is now? What is the problem here? Offset is the nodes. And the offset, of course, this is okay. Are same. Then pushback I. Why won't this work? Component ID. Component ID. Well, anyway. That's easy. You're gonna do it. You're gonna do it. You can do it simply. Okay, so I have to debug why is this not the case here. Components. Okay, I can do this. Program log info, and then I can go comment. I mean, it's just simple somewhere. Get all nodes. Maybe this get all nodes and components does not work properly. Maybe this is the case. Something in here does not work properly. Oops. But no, this worked properly, I think. In component size, component ID, merge with this ID. Offset is this size. This is correct. And we just want to say that how many components are here. Components. Oh, maybe it's not even. Okay, let's just do that. Let's go into debug mode. Let's apply that. We'll pretty much find out what's going on. If there's just one node in that when we here push this node, visited. No, the result pushes this node. Okay, and then it inserts into visited. So okay, so it's fine. This should be fine. But even if we have now these components, do we have to actually, yeah, we kind of want to know when to stop executing. We kind of have this component. We just execute nodes that we need to execute. This is essentially the same thing as like doing SQL query planning. Kind of pre-compiling something. Okay, so like execute that. Now here that should be okay. Now that we have components. Okay, now we don't have nodes here. Okay, there's just one component. That's correct. Generic. I'm just gonna copy this node a couple of times, and I'm going to do that. Now I'm going to execute that and going to go through the nodes, the DSU, mnode size, component ID. Why is this in hacks? How to change this in like, okay, yes, 20 nodes, okay, whatever, that means that looks this, that okay, so we kind of have this in component 1 and oh, node graphs accept, no, yeah, accepts node components. Wait. Node IDs is 3, 18, and 19. That's correct. DSU kind of merges 23. And it says that they're not the same and they're not the same. What? No. Wait, I need one more time. Execution this policy. Okay, so we have 1 in the third component. This is not correct. You cannot be just 3 here. So this is not correct. Set visited for each node. I'm gonna push the node. I'm going to query that. Okay, visited count T, then continue result push. Adjacency not visited. Oh, reverse is the reverse that we actually want. Oh my god. Oh my god, it's like that. Stupid, okay. Yeah, component counts is 2. Now here it should be 1. Okay, cool. Now if the component counts are found, then we want to, okay, so check if there's multiple components. Node graph component count. This is the thing. Execute, okay. So for each component, analyze the anti-chains. The anti-chains are essentially, what are anti-chains? So anti-chains are so you have some directed acyclic graph. And the anti-chains are chains where one node does not depend on the other node. It's not that it does not depend on the other node. Like exactly, they can be executed in parallel. So exactly that this node and this node can be executed in parallel. So, and this node can be executed in parallel. And then like after, like if you had some other node here, then this node can be executed in parallel with like all of the other nodes. But we don't really need to analyze the anti-chains if we're executing in a BFS order. So we just kind of say, okay, we schedule jobs for each component. For each component, we schedule jobs. Then, like as jobs execute, and each job we just execute this node, then execute some other nodes that can be executed in parallel, or just don't execute them in parallel. So we don't actually need to analyze the anti-chains, but immediately go into the execution of the BFS order. Now that the components are separate, I will want to make a function that will execute each component separately. And the thing is, given this component's IDs, is it possible to figure out the topological, or how fast can we figure out the topological order? Yeah, this is quadratic time here. I'm not proud of this. This is quadratic time, but whatever. There are not going to be that many nodes either way. Lead code. I don't kind of do that much lead code. I just do daily tasks or something. It's quite. I mean, I haven't. It's not here. Let me just open it here. I haven't been on that much competitions on lead code. Just quite. Oh my god. I have like 230 problems. I try to solve just daily puzzles, and I'm just 2,100 rated, but I haven't been on competitions that much. Just 9. It's not that much. No, I mean nothing. I should solve more, but I don't have time. I don't have time to solve more. I'm sorry. Just thesis, papers, and all of these other things. It's just so much stuff to do. Execute in the BFS order. Okay, so no, I'm not going to do that in quadratic time. I'm thinking of doing this like. I mean, okay, we'll optimize it later. This is quadratic time now, but whatever, we'll optimize it later. It can be done in like often, but okay, whatever. Executing the nodes in the BFS order is now a little bit tricky. Is the sense that there is topological sort for one component. Yeah, so let's do this. Okay, so there is already a function about topological sort that I have implemented way back. Get topological order. Get topological order by components. Calculate the combined topological order of all provided components. Get all nodes in the components on a topological order. Now the topological order is like full components. If it's not visited, get topological order. Get topological order is what a function that just goes and says adjacency. So this is like adjacent to this node, and I'm going to like do that. So is it possible just to say, okay, this is, I care about just the dependency of this, and then I can get like the topological order of get topological order by components of all provided components, and then, but why is this adjacent? No, this is not good. This is not good. I want to recall this function. Run topological order. I want to recall this function because this is get full components. I'm getting on the full components topological order, but I don't want that. I want get topological order to be like in the reverse adjacency list. And then this is reverse adjacency, find ifs, reverse adjacency, get topological. But no, this is what is adjacency and what is reverse adjacency? I already forgot about that. So reverse, the adjacency is on this side, right? And reverse adjacency is on the other side. So the reverse adjacency list, this is that. No, we want reverse adjacency. We go through all of these. If it's visited, so we go back, right? Then we go extremely back on this component. Then we say order pushback u, that is correct. Visited u, this is also kind of correct. And now get topological order DFS should go through now we don't need to reverse. Get topological order is like, what? Is this even used? Calculate the full topological order of the graph nodes that if there are multiple, some of them might be mixed at the end. That is correct. No. I think we're mistaken here about the adjacency maps. Let's just figure out the adjacency maps because I think this is mistaken. U pushback V and V pushback U. What is U? U is this. Okay, so we're not mistaken about the adjacency maps. Okay, get full topological order. I don't think we actually kind of need that. Get topological, or maybe we can just comment out that this does not work. Get full topological order by components is the thing is that, okay, we have to get topological order for these components. We go and we reverse no. Get topological order. We're already in the reverse direction, and we go through here. Get okay. Now that we're here, now that the order is done, a topological order for each of, so for each of the components for int component for we're just going to have a vector of the nodes in this component. The nodes is this component is again quadratic time if I iterate through the nodes. Reverse maps on these things, it won't help us. It's okay. If DSU are same, the I and component ID DSU are the same, then we push back this I node. Then in the nodes we get topological auto order. We get topological order by components and then provide the nodes. Now that we have this topological ordering, we can execute them in in order or something. And this topological order will get us the way we manage this. Okay, I will maybe improve that off camera. Not sure. But now that I have execute okay, let's just maybe execute it even here. No, you have to have a function. Void execute in order. In order, and let's assume that this function executes this is going to be a massive function. Okay, why not using yesterday? It's a policy. We do not this is production code, so using std, when you write using namespace std, what you're doing is you are making all of the variables, I mean not just classes, definitions, accessible by default in your namespace. So this just makes your namespace, how do you say it? It makes your namespace bungled up with other data that you don't need. So if you had a function that is like transform, here, and you're already using namespace std, the compiler will kind of ask you, okay, do you mean the transform from the namespace std, or it's ambiguous if you create a function that is called the transform here. So like I mean, it's not ambiguous in the case that, okay, it's another overload, but it could be ambiguous. So you don't want to do using namespace std in production software. What you're doing in software where like in competitive programming, you're just doing this to gain speed, but in production, it's a policy that you don't pollute your namespace with garbage you don't need, and always you are defining your own namespace up there. So when you define a namespace like this, like Gamma Fusion Node Engine, when you define whatever other namespace, like namespace blah blah blah, all of the functions that are accessible in this namespace here, so like all of these member lists, there are this namespace is not polluted unless you have some like global functions, and most of these global functions here that you see are probably Windows API functions and some Windows API things that, like, because Windows is stupid and it did not use namespace, and main other codes in C. So like when you have in C, there's no namespaces, so I mean, it's a bit but it's cool to use your own namespaces. And then don't pollute them with. If I could just make my own namespace and just like not pollute it with anything else. But okay, so this is order. This is the order. The get topological order by components is the order in which the components should be executed in this component. But now I just want to kind of see if this is correct. This is more, I'm just kind of hello. We're doing some execution of node graphs for parallelization of an execution of node graph, but it's very complicated in a sense that it's not straightforward to parallelize node graph, because you have to think about all of these kind of things, like, okay, what if you have like two components like in the node graph, and when you want to gain, like, sometimes what you want to do is, like, you have some node graph which is like this, it's a directed acyclic graph. And sometimes you want to execute this node, let's say. So to execute this node, I don't have to execute these nodes. I just have to execute dependencies of this node. But okay, now what happens if I have another node that I want to execute it here, but this node is dependent on these nodes? So if I want to execute this in this node, then this node will be executed as well. So this is now the graph. And now, like, there's so much stuff to cover, and you have to be really careful how you're managing things, and also it has to be fast. It has to be fast because you could have some big node graphs. So in the components now we have one component, but the order of execution is given like this. 0, 1, 2, 4, 7, 10, 11, 12, 13, 8. I would guess that these nodes here and these nodes are the 5 nodes that we have generated. And then 9, 5, 6, 3, and okay, so this kind of looks like the execution order. The node ID, I don't know if I have the node ID printed somewhere. I think if I go on a debug screen and I maybe select a node. No, I don't get the node ID. Maybe if I right click, no, I don't get a node ID. Maybe I should actually just print a node ID somewhere here on the tips, like description of node and then like some node ID. But I don't want too many tips, you know. Maybe just in the debug. Okay, so let's just add that to the controller here. Let me show you how you add that. Not the controller. There is the node editor .cpp, and there is this render debug info. Where is this render debug info? And this just kind of renders some things here. And now I want to say, maybe I want to render this if m selected nodes. The selected nodes is an array that keeps which node IDs are selected. If it's not empty, there is a function there. I can do IDs, then there I can do core string. What's my setup? What do you mean what's my setup? Core string, and then there is an interesting function that's called join, which is implemented in our namespace, and then the vector is the strings, which now node IDs, join string is like this, but now node IDs has to be a vector, and then vector std string node. Yeah, this is too. Maybe I can override this kind of function that the join. Maybe I can add a join function where I can actually, instead of basic string, I can get a vector. I can get a vector of arithmetic type. That could be cool. Your IDE, OS, and setup. This is Visual Studio. This is, I don't usually code in Visual Studio except for my job. So this is my job. I'm coding in Visual Studio. Actually, I code in Visual Studio Code most of the time. So for personal projects. The OS is Windows 11. I always use Windows 11 because basic string. Oh no! Basic string is a type of. It's a typed string. We can kind of do. What is basic string actually? As a question, as with the Vim extension, no, I don't code. No, I don't know Vim. Actually, it's on Visual Studio Code. I just have the CPH Judge and some few other extensions. Oops, sorry. On std basic string. Okay, I'm not sure what basic string stores. Let's take a look at the documentation. I like extensions, and I have coded and some open source extensions and some other things, but Visual Studio offers its own way of doing extensions, but I don't like coding in some other proprietary software like IDEs like Vim or some other things, because it's painful to set up projects that are actually Visual Studio solutions there. And if you have already a Visual Studio solutions, you are like, it's like impossible to set up in some other IDE. And I have tried to set it up in Visual Studio Code, but it does not work. Okay, so what is the basic string actually? It's okay, it's class type basic strings, character which are non-array types. The elements basic string are stored continuously. So basic string just allows you to define like other variable, like other types that that kind of the character widths. Okay, so should we? So STD string is just the definition of basic string character. I think it's better just to do join and then const std vector and then do like a type. And then vec, and then const std whatever string is just enough, join str. Instead of basic string is just enough to return a string. And then the thing is that the thing is how to check is like I want to do this std to string vec I, and then do std string result for auto element in vector result plus so okay, so it does that, but it's the same thing. Result or append whatever vec. I don't quite like that. I like this more. Result plus equal this plus I is smaller than vec.size. Vec.size that -1, then join str, otherwise this, then result. Okay. What did I I have to go into release mode. I don't know if it's ambiguous between this and that, because if this is a string and this is a string, this can be ambiguous. What is my job? My job is coding. No, it's coding. I work in a laboratory in the faculty, Gamma. It's a geospatial laboratory. We're working mostly with geospatial data. So like images that are like reference to some geographical position, or like data that is like from sensors, from different types of sensors and different like different parts of the globe, and like all geodata, mostly geodata, and there's like artificial intelligence as well, but mostly geodata. Join. Oh, this is ambiguous. Join. How to make it non-ambiguous? You can't. Other than like renaming this, you can't, because this type and this thing here, other than saying like type name some other thing, but it's stupid. Okay, you see, like adding just one function in like production database, like in production code base, could really make, because basic string can be casted from anything and string can be casted from anything. It's really hard to decide. Like I mean it's a function, but I wouldn't just add this function here because it might break some things, and some things might not compile. Then you're guilty because some things might not compile. I'm not even sure if this is ambiguous. I think it is. I think it is ambiguous, and I think but to string here, like the thing is, what happens if you have basic string that is what happens if here t is basic string and then this is not a basic string? This has to be like something like to kind of completely code this. This has to be like this, like that, and then we have to return a basic string of t. Yeah, I can kind of delete this function. And do const expression here. Kind of can delete this function and do, but there was some kind of function that will like make to string here, replace format string print. Wasn't there a function that does that? Contains, because if you break some function that is used in most of the code space, is very bad. Okay, let's not break this. Let's just copy this and call it for ourselves right now, because I don't have time to test out what happens in other areas. I'll just do that. Result. I'm just going to do mSelected. Notes. Let's not just break the code base, because this is gonna be okay. This is cool. Then debug info plus equal std format. Then this is what terminal. This is selected IDs, not identifiers, and then you do result. And now when we do that, should be fine. Should render now the. Of course, I made it in the release, but whatever. Yeah, template magic in C++ is very nice. Yeah, thank you. No, I mean I have worked on a lot of things. And of course, electronics is very fun. I would love to work on more electronics, but you only have so much time in life to do things. Template magic, I can rewrite this function with a little bit more template magic. So if like some things are convertible to string, then this should accept them and should rewrite this function as convertible to string. Also here, like to lower string, like it should accept other things instead of just string views. Okay, other things we need. Okay, so selected node identifiers, we have the ordering. Now the ordering can be executed as such, but we kind of want to know. So guys, just how long have you been coding in C++ for? Very long. So I started coding C++ from first year of high school, so that's 2016. So that's like 9 years. 9 years, and I have been coding back then, like in C sharp or some other languages. So yeah, so that's a long time. Pop. Okay, so this now I should get in the debug mode. If I select some nodes, I should know. So this is node 0, this is node 1, this 2 and 3, 2 and 4. If I go into this what is very interesting is like if you want to know what I'm working on, you can just kind of go back on the first section of the live stream, and it's explained pretty well. But the other thing is, like, I have seen this, like this we always just see this drama between pirate software and other. I don't know if you have watched this drama between pirate software and Stop Killing Games. I don't know, like Stop Killing Games. How much is now Stop Killing Games? How much do we have petitions for? Oh, they're going pretty well. Nice. No. C++ Pro is. I mean, I know people that are way better in some aspects of C++ than I am. But there is so much to the language that even if you like, there is two languages in one. C++. It's essentially like you have one language that is the language, the C++, and then there's like template language. And what are you good with? I mean, there are a lot of stuff that but I can't, like, it's very hard to say like it's good with. I can be good in anything, it's just takes learning. But there is this. I want to learn a little bit more about like STD template stuff. Like there is these concepts. I know a bit about concepts, but there's this in C++20. There is these concepts, and I have because we're not programming in C++20. We're programming in C++17. I haven't really got around to these concepts, but there are so much stuff here. There's so much stuff, and I don't think in the world anybody knows everything that is in the standard library in C++. So there's like always something to learn. Then there's this C++ like same as, right? But there are also all of these other template magic stuff that you can do, that like incredible stuff. Like I know mostly like the basic stuff, but there's like remove CV reference. What does this even mean, right? If the type T is a reference type, removes the member type def type, which is the type referred to by T with its topmost CV qualifiers removed. What? Okay. But there's so much stuff but this is since C++20. This is not in the 17 version. So there's so much stuff that they add, and it's hard to stay on top. The C++ is a really incredible language. I mean, Rust can just eat its It's not coming any close. All macros, they just use macros on Rust. Get topological components. Okay, so we have the ordering. No, I just want to see how does the ordering look. Also, I have built it for release. I want to. Oh, fuck. I want to build it for debug. I want to see the topological ordering and see if we're right on that. Then when we have the topological ordering, we're just going to execute each node separately, and it should be fine. We should get the same execution as before. But then applying the just-in-time parallelization will require us to do some performance gathering. We already gather performance. We just need to compare we just kind of need to, and also threads and thread pools, to design thread pools. Oh, that's insane. There's so much stuff to do, you know. Come on, what is now? Do we have some errors? No, we don't have some errors. We have a bunch of warnings, but the software we're developing is like what, 10-15 years old, so there's a lot of stuff inside, and you always get some warnings. Okay, so like I will execute that. That should get us the topological order of the components. Is there a way to just, yeah, there was a really cool way of like get raw view, then get first, right? Then this is the address of the first, right? So if I just go, let me show you something. Let me show you something cool that like you cannot do with other stuff. But what is this? Where was this watch window? Okay. Let's just and this here add item to watch, and you just kind of, let me just open a magnifier. What the? How laggy is the magnifier? Windows Plus fix stuff. Okay, so and we do so appoint this to an int, right? This is 0, but there was an idea, I don't know how, but like there was a cool thing that you can do, that you just kind of, because if you do like one here, it will just, of course, now this is maybe no. What, you convert this to an int based, and then you, because you can do stuff like that. Yeah, so you can do stuff like that, and then you can do 2. What is the second element? Then you can do 3. What is the third element? But then there was idea that you can do how is this so fucking laggy? There was this idea that you can, let me Google it. Visual Studio watch multiple elements of array. The pointer to the array, and then this. Okay. Oh my god. Oh, this works. Oh, let me show you with the magnifier. What is this now? Come on. So this kind of works. How long did that project took? Half a year. The node editor. Then it was really fun to build. So you can do that. You can just say this is an integer pointer to this address, and then this is the address, and then 10. Give me the 10 first node, the first elements of the array. What if I go more than what it is? Oh, it goes into the address and it doesn't say, okay. It goes more than this. So kind of cool. With a group, yeah, no, alone. No, the node editor is alone. I had a little bit of help from a colleague, but mostly alone. Yeah, mostly alone. 0, 0, 1, 2, 3. Okay, so let's now compare these nodes with what we got executed. Okay, so let's go here. Let's now compare these nodes with the node IDs. So if we go into debug mode, this is 0, then this should be 1, then this should be 2 and 4, this is correct, then this should be 7 or 8, this is correct. So these are in parallel executed, whatever, that does not really matter. Then after the executions of the parallel nodes, this should be 9 or something like that, which is correct. This is 9. This is 5, it is correct, this is 6, and on the end is 3. Okay, so the correct order is correct. The order is correct, it's cool. The project was not, yeah, the node editor is from scratch, like from me, like there's like a lot of lines of code. I don't know, probably, I don't know in what order of lines of code. It's, I would say 15, 20,000 lines of code, maybe. I don't know, a lot. Okay, the order is here. Now we can execute that. Execute in order, and then provide the order. Now here is to do parallelization. I mean, it's half a year, no work, a lot of work put in here. Now execute in order. Execute in order should return some kind of integer, which is a result. Also, a result should actually, like, we're now getting like an integer here, and then this is kind of result. Let's just do scope performance here. In execute in order, then now execute in order should get the execution strategy from the the execute imapple function. Execute imapple function is a function that executes one node internally. But I would want to create a new function that is like void execute node, and this is like node, actually not void int. This kind of function will just exactly execute one node, because execute imapple does some things other than just executing one node. It does much more than executing one node. first this execution pull is like, okay, if it's computed, and then there's like cyclic dependency checks. Cyclic dependencies checks are real, and we should check that, but before even the graph is executed, we should check cyclic dependencies. So like in the nodes itself, but that's not cyclic dependencies. Yeah, I'll check cyclic dependencies with the DFS because cyclic dependencies. But okay, that's to do. Oh, wow, there's so many stuff to do. This checks cyclic dependencies. This now we don't quite need. But getting a current node, getting computed, the status of the node, we set the status of the node to what it is. We put it to the stack. Now we're not longer going to have stacks. Inputs of the current node. Kind of want this code here, I think. Kind of want this code into execute node. Okay, current node is going to be nodes at node ID. So current node let's name this output node ID. How do you know what code is it? Just what to code is just for practice and logic? No, this is actually for my master thesis. So we're coding for my master thesis. No, I code for fun sometimes. Yeah, but I code for job, and this is kind of for master thesis and for the job as well. So because this project that I'm doing for the laboratory is going to be a part of the master thesis. So yes, so this is kind of both things. Check if there are inputs, but if you have like I mean, I have GitHub, so like there's I can show you some things here. Let me just go GitHub. Of course, if you kind of look for some competitive programming solutions, or some Atlas is the open source competitive programming library that I'm kind of creating here with just some algorithms, collection of algorithms. Then I'm also working on like on a forward library, animations, of course, and some other projects as well. But in the last month, I haven't contributed anything to the GitHub repository due to just immense work. Check if there are inputs that are not filled. Get required properties. Required properties is not null. Okay, this is what are required. Then like these are node edges that go like from this node to reverse to some reverse nodes, and say okay, which are filled. Then if required is empty, then this is request from a previous node. If required is this, then this is some status that we're here implementing. Let's just define status. Now that we are requesting from a previous node, now this is not requesting from a previous node. This will not exist now. Followed you on GitHub will watch. Yeah, thank you. There's always some cool stuff to do. VID is the reverse node. This will need. We're not going to execute that node because we kind of actually already executed these nodes. We kind of think that they're already executed. We assume that they're already executed. We can just assert that they're already executed actually. we can just say mComputed, which is VID. Now mComputed will return an nodes that are computed in this execution run. But what was computed actually? Yeah, the status. So we assert that this is, if this is not successful, then I'm just breaking it here. I'm also trying to make a chess engine. Only the problem is that I'm learning C++ now. My first problem will be this. Like the chess engine. Yeah, without ChatGPT, of course. Yeah, like ChatGPT is just brain killer, because if you know that ChatGPT exists, you will do everything like with it. So like I just try to avoid it as much as possible. I use it only for stuff that like I know that like for some plots, let's say. You need do some matplotlib, and then you don't know what variable is what, and then ChatGPT is very good at that. But for huge code bases like this, like let's say this file is 900 lines of code, and then I want to do exactly, I know what I want to do, so it will just slow me down if I use ChatGPT here. mComputed is some execution status, int execution. Oh, also instead of execution status being a what I can do is very clever actually. I can do the execution status. Where was defined the execution status? Okay, there's the deferred. I can define. I don't know if I can access it now here, but what I can define is I can define there is this flag set, and I can do execution status. Then I can do using execution flag set, and then this flag set is, I think, in the where is this flag set? Flag set, not flag set. Yeah. Okay, cool. This flag set is a cool little templated structure that kind of contains a lot of magic for like flag setting and stuff. I'm talking a bit of out of topic, but have you ever made the chess engine? No, chess engines are incredibly hard. Not because like I haven't needed to do something like chess engine. I have coded some other chess thingies, but like some interesting night walks and solvers and whatever was that. But the thing is that chess rules, just coding chess rules is incredibly hard. Just because you have to account for all of these all of these kind of little exceptions, and I wouldn't even want to start coding chess rules. There was a professor of mine that said that he gave to his students chess sets. I mean, he gave to his students chess to code the chess rules, and then no one actually did it. No one actually coded successfully all of the rules. So yeah, chess engine is something that solves chess positions, or just an engine to implement players playing. Yeah, that's one other thing, yeah, as well. do you implement just implementing two players playing is just incredibly hard. Okay, execution flag set, and then I can return, what I can return is execution flag set, which is incredibly interesting. We're streaming 2 hours and 40 minutes. Okay, so the plan is just to stream to 3 hours, and then maybe just, okay, so let's just do the execution flag sets. Let's define this execution of the node. Let's define it as an execution flag set. Then also in computed, we can define as execution flag set. Then it is very easy to say if it's computed has, and then we just kind of say execution status success, anything other than success. So if it does not have a successful thing, then we kind of want to probably break. Also child, status of this node should be also computed vid. Okay. And then this is kind of cool. And now the outputs and the inputs are being gathered from the other node. This is type conversion stuff. Blah 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 blah. This here I can make the status to be execution flag set, and then of course execution flag set, and then execution status none. The execution status should be now defined properly. Success is 0. No, success cannot be 0. Should be like properly missing cache, not executed. Used as default internal value of the node has not been executed. 0 has to be not executed, because it's easier just to plop that in. Not executed is 0. But now this is not error code, like not executed is 0. Success is kind of 1. And then all of the others are shifts. I think this is better. Also, for now we can do that, but we can actually shift that later. 8, 16. But then there is this execution status, and there's this function here below that if it is 1, these are all the cases. Success is 1, and then these are errors, which is kind of a little bit nasty, but whatever. Execution, I wish, no, is this VS Code? No, this is not VS Code. This is using vanilla Vim for a large project like this might be. Yes or no? No, this is not Vim. This is Visual Studio. This is Visual. This is the large, the bulky, the expensive, the Microsoft stupid software Visual Studio. It is like it's laggy. The syntax highlighting doesn't work that much, but it's the only software that supports incredibly large softwares solutions. I'm not using name SSD because I don't want to pollute my namespaces. We have strict company policy. This is status add property missing. We just want to add to the status property missing. Also the status has this yeah, I can yeah, let's in the flat set make an operator, define an operator which is this. Of course, this is flag set, then you do this I think, and then you do some other either flag set or some other things and then you do like you do value other dot value, return this, something like that. Also template this is not the operator. Flag sets. What is why is this not the operator? How do you define std C++ define this bitwise operators? Custom bitwise operator. Why is Google so stupid? Why cannot I just define custom or operator? Oh, it's the same idea as you define. Oh, of course you define. What? How stupid! You define this. Of course. Why don't just use this, of course. I'll figure it out faster on my own. Okay, so this now operator should work with okay, so the status not executed by default. Voice access, what? The executed, now this works, now this operator kind of works. This should also add property missing. If my status contains a property missing, report it. If my status contains property missing. Okay, this is just for reporting and stack tracing. Because the node editor actually has stack tracing inside. So like when some node is executed, you can stack trace where this node came from. And now that we're executing in BFS order, there won't be any other. There won't be an easy way to stack trace. So we have to kind of maybe do some other things, because this won't work. Now status of the children. No, there's no children now. This is the only status. Status 0. Okay. Status at crash. And now this is return status, and the status that we're returning here is an execution flag set. Also on the executed on which execution flag set we have execution flag set execute email puller does not need to be done here. This is not anymore valid. Execution status execute node. So this kind of needs to be executed of the node. Try set. Yeah, I mean, I would rather go to Visual Studio Code if I could make the project, but it just the solutions are so big that there's no way to. Visual Studio has its own management of its own solutions, so you cannot just completely go to another editor without finding a way or plugins to manage the solutions. Now this does not work. This won't work for the flag execution. Blah blah blah. This kind of thing here. But let's just say that we have some flag set or some execution stat. We're gonna go and back fix things. Execution status not executed. This doesn't work, but now that we're executing in order, for easy execution, just to finish the live stream, we can have just this in the order, and we can go and we can say execute node, and I can provide the node, and the execution of this node should just trigger this procedure where like all this blah 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 will just execute the node, will go this and property missing blah blah blah, report that, report the status. Now that we are executing in order, execute in order, now we can here also get like execution flag set, and execution flag set could also be execution status not executed, and then we can say result append this execution, then result now execute in order should have the flag set. I love C++ because it can, like, you can do template magic, and this is really nice. Okay, so now let's just build the program. Okay, we have some errors, but this will be fixable. These are fixed because I want to end the live stream like around 3 hours, so like that's nice. Now execute. Okay, execute just has to define flag set. That does not really matter. Also here flag set result execution status not executed. Okay, let's build that. I think it passed, or no, it didn't pass. Of course, we're returning this. Did it build? What is this now? Flag set, no appropriate default constructor available. Where? Oh, on the map. Okay. Well, so on the flag set, I could say that I could either add here flag set default constructor that is like value 0. I mean, I don't even need to do that. I can just do that. Now that it's 0, it's going to be fine. You can code Yeah, yeah. I was thinking about coding extension for VS Code that will read the solutions from Visual Studio, and it will know how to build them. But oh, it's ambiguous. What, the operator is ambiguous? How is ambiguous? But of course, because we're using execution statuses. Yeah. Okay, this. We don't have to execute this for now, or just execution flag set. Oh, this is in the node graph, in the node engine. I was thinking of building the flag. Oh, flag set. Did I name flag set? I'll have to rename it. Execution flag set. I have to rename that. And now here, this is not an int, you know. We'll have to rename that because I hate naming. I have strict naming conventions. It has to be flag set. But okay, so this has to be int. I was thinking of creating the extension for VS Code, but it seems that there is a lot of things that you need to cover in order for the VS to the Visual Studio solutions to even load. So I decided not to embark execution buffer node engine execution flag set full result. Where is full result being repeated? Execution flag. Buffer node engine execution flag set, and then full result is being here implemented. Oh, this is if it's successful. So has buffer node engine node engine execution status success. If it has success, I think this should work. Yeah. But now the thing is that if you want to code C++ in VS Code, you have to have either Makefiles, CMake, or something similar like that. But there's no way to in MSVC to code in MSVC. There's no way. Import this graph. Okay, let's just go execute. Okay, then there's some bugs. Node image metadata failed. Property image does not have its value set, which is required. Okay, but it executes them. So this is a huge step. This is a huge step towards the execution, but it's not set up. It's probably because it has something to do with. I mean, we already had it executing on the like, if we go DFS, and if you go back on the live stream, you'll see like we have executed that and all that. But now that we're doing JIT parallelization, we have to execute it in a BFS way, and in this way, this has to be like something has to be like out of order here. Result is here. Result is getting this node. Oh, the thing is, what if some node is asynchronous? No, it should be okay. execution R node, so R nodes if it's not computed. Yeah, it's not computed, of course, but it is computed. Oh, okay, this is a little bit of this, but okay, this will be fine. Blah 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 blah. Set status execute, then this output node ID is like execution start status and then success. This should now work. At least like just executing the graph. If I get just executing the graph in this BFS way, then this is probably not, oh, of course support, whatever. It's like loading old graphs crashes it, okay, whatever. Okay, cool. It's executed. Okay, it's not reporting that it's correctly executed, but it is executed. So in the images here, yeah, it loads the image. This image should be the same as the image prior to these manipulations, because these cancel out. And as you can see that these are two the same. And what is very interesting is that this image editor, image viewer, not editor, image viewer is coded like with GPU acceleration in mind. So like this is GPU texture, and I've coded like a bunch of like stuff to just like load that in a GPU texture and just to get the GPU texture. So like I can then load like 3D models in, or like load some other things in as well. But so like this should be the same, and now I don't know if it will be executed once more, but yeah, okay. No, but now if like I add like 100 to make just see like what was the operation that we were doing, no, multiplication by 2. Okay, this does not feel, this should update the same way, but maybe this component wise does not work. Let's just execute this. Okay, this now works, just white. Okay, whatever. It should. I have to fix some other bugs in, but now that we have in BFS order, the next step is to just make thread pools and thread, but that's way far. Today I'm streaming like 3 hours, so I'm not gonna stream more because I'm too tired. But thank you guys so much for watching. I hope you to see in the next stream. We're going to be coding again JIT after fixing a little bit of the camera, a little bit of the code, just making it nicer. Then going on camera and then actually doing thread pools and thread management and syncings and other things like that. And yeah, that's pretty much it. So the node editor is pretty interesting, pretty cool. There's a lot of stuff going on. There's a lot of stuff in the background that is happening. There's like the nodes, the structures of the nodes. I will make a separate video on explaining like all of the features of the node editor till now that they're added. And then there is this, I don't know if I can share, but there is this like I think I can. Let me just open just to show you that like there. I don't know if I can share it, but there is a whole presentation for the node editor, and then like. This was actually the presentation for the laboratory, because I pitched the project. So this was the whole idea, that the node editor, each node is a function, and each function is an extension, and then there's a lot of stuff that like each node can render, and what you actually what you need to support, and how this how the infrastructure works, how the renderable side and how the execution side works. And then there's like how do you specify and register nodes, how do you register. And then there's like okay, you have to because I built this node editor from scratch, I had to build a rendering engine. So how does the rendering engine works, what kind of things you can do inside the rendering engine, and like some diagnostic stuff that the rendering engine kind of shows you how are set up. So the GUI itself is in C++, so kind of cool, yeah. But we'll make another video on that topic a little bit later. Thank you guys so much again for watching, and I hope to see you all in some future videos, and check out the channel for other content as well. Thank you so much for watching.